and welcome to our last lesson in Chapter 4. Today we'll be talking about ways to reduce variability when you're designing experiments. And we're going to be looking at 3 experimental designs today, each of them valid in their own right, but each of them different in the way that they reduce variation. Like, we know that there's variability. But if we want our experiment to be good at determining causation, then we need the variability to be because of the treatment that you're giving, not because of the variability within the subjects that you picked or within the treatment groups themselves. So to help us with today's lesson, we're going to keep this scenario in mind. We at Heart Healthy Pharmaceuticals, that's us, have developed a new cholesterol-reducing drug. We want to test it at 2 different dosage levels, and we have a group of 100 subjects, 50 men and 50 women, who have shown some willingness to test our drug. Okay? The first type of experiment that I'd like us to think about is one that's called a completely randomized design. In a completely randomized design, the 100 test subjects that we have, so we're going to kind of build some flow charts here. Our 100 subjects would be randomly assigned to one of 2 groups, since we're testing at 2 dosage levels. Dosage 1 and dosage 2. It's important that you recognize that the random assignment happens here. Once we've divided our subjects into 2 treatment groups, we give them our new cholesterol-reducing drug, and after a reasonable amount of time, we do some measurement, probably looking at cholesterol levels in their blood at each of the dosage levels, and then we compare results. So, if you think about it, what we said yesterday is that every experiment needs to have replication. We have 50 people in each of our groups. We need to have randomization, which we've done here because our people were randomly assigned to their dosage group. And then comparison happens at the end of the process. That's a picture of a completely randomized design for our experiment. Another type of experimental design is called randomized block design. A block is simply a group of subjects that share a similar characteristic or characteristics, a group of subjects that are alike. In some regard. In our experiment, we might want to block by gender because we know that men and women often have different reactions to medication. We might consider blocking by age, since cholesterol is probably more of a problem with folks who are 40 or older than it is with folks who are younger. But blocking is a way to minimize variability within the group of people that you're testing. It minimizes variability because you're looking at groups that are somewhat alike. If we were going to set up our experiment to be a randomized block design, we still have our same 100 subjects. But this time, we're going to separate them first, and I am going to choose to go by gender. We're going to separate them into a male group and a female group, since I think that gender may have something to do with how they'll react to the drug. Once those assignments have been made, then within each subset, we're going to test our 2 dosages, randomly assigning men to one group dosage or the other, and the same thing with our female subjects. Dosage 1, dosage 2. After a suitable amount of time, again, that's when we'll want to take some measurements from our groups. After we have our measurements, we can compare within the genders. And compare overall the results for men and women. So a randomized block design separates the subjects by some characteristic. You try to set up groups that are as alike as possible. Then the members of each of your groups are randomly assigned to their treatment group. You take the measurements after a suitable amount of time. You can do comparing within the blocks and overall between the blocks. Randomized block design. The last of the three methods that we're going to look at today is a special case of that randomized block. This is called a randomized pair comparison, or other places call it matched pairs design. In this case, instead of creating two subgroups, we'll take our 100 subjects and we will pair them up. So we're going to create 50 subsets, not randomly, okay? And I can't show all of that, obviously, but 50 groups or 50 pairs that are alike in some fashion. That is, you set them up into groups that you think will react to your drug in the same way. Again, the deal is to try and limit variability. So within your group, you get people, or try to get pairs that are as alike as possible. 50 pairs of alike people. Then within each pairing, okay, so once we've selected, within each pairing, we're going to give one partner the first dosage, we'll give the second person the second dosage. This is where randomization happens in this setup. And we're going to do that with all our groups, and I'm not going to show all that, but we can compare again within the pair. And we can compare each of our 50 groups, right? Compare within each of those. And again, final comparisons could be made, okay, to see if you could come up with an overall consensus that one dosage was better than another. The randomized pair comparison only works, folks, if the groups that, or the pairs that you pick, are homogeneous, that you want them to be alike, because what you're trying to do with your blocking, with your pairing, is reduce variation within your group. Okay, you want them to react, or you choose them so that you think they'll react as alike as possible. So we've looked at really three different setups for experimental design. Each of them combine the three necessary things for experiments, which are repetition, randomness, and comparison, right? All three of our methods showed all three of those essential elements. Random, replication, lots of replication here, comparison. So I hope that you will get out there as soon as you can, do that U-Try tonight, and we will see you in school tomorrow.